Our focus is going to shift a little bit. We're still talking division, okay, but now we're going to be dividing polynomials by binomials, okay? Um, it's nobody's favorite thing, okay? It's not necessarily difficult to do. It's a little messy, okay? So you have to be really neat and organized. You got to watch your signs. That's going to be a big thing, okay? But before we dive into division of polynomials, which we use basically long division to do that, I want to remind you of the steps for long division with just plain old numbers, okay? So I've written out steps, but as I was writing out these steps, I was like, gosh, this is confusing. It's confusing. It's hard to write out the steps to division, so bear with me. But the steps for long division, you divide the first digit of the dividend by the divisor. So actually, that brings me to this topic. When you have division, there are basically three parts to a division problem. You have a dividend, a divisor, and a quotient. Okay, so let's say we have 12 divided by 4 equals 3. This is the dividend. So the dividend is the number being divided. 4 is the divisor. The divisor is the number doing the dividing. And then the result is the quotient. So you will hear dividend and divisor. So make sure you understand the difference in those. It's easy to confuse them because they sound similar, but dividend is what's being divided. Divisor is what's doing the dividing. Okay, so with that said, you divide the first digit of the dividend by the divisor. You write that result above the dividend in this like long division setup, which will make more sense when I show you. You take whatever you put in the quotient, you multiply it by the divisor, and you subtract it from the dividend. Okay, that first digit of the dividend. And then you bring down the next digit and you repeat the process. And then you bring down the next digit and you repeat the process. And you keep doing that until all of the digits in the number have been brought down and you get a zero remainder, ideally. If you don't get a zero remainder, we have a way of dealing with that. Okay. So again, sometimes when you read the steps, they don't make loads of sense until you see it in practice. So let's do this. So remember, we're just doing numbers right now. We'll look at the algebra next. Okay, so example 1 says find each quotient. So we set up for long division. So I want to take 872, that's the dividend, and I want to divide it by the divisor of 4. Okay? So I need to ask myself, okay, how many times will 4 go into 872? That's what I'm looking for overall. But sometimes that division isn't easy for us to do in our head. So what we'll do is we'll divide piece by piece. So what we can do in our head is 4 into 8. Okay, so how many times would 4 go into 8? Well, 4 goes into 8 twice. Okay, now what I need to do is take that number that I've put in the quotient, multiply it by the divisor, and subtract it from that first digit of the dividend. So 2 times 4 is 8, so I subtract that from 8. I get a 0, but I have digits left to drop down, so I drop down the next digit in line, which is a 7. And at this point, once I drop something down, something has to go in the quotient. So that's when you kind of repeat the process. So now, how many times will 4 go into 7? Well, 4 only goes into 7 one time. 1 times 4 is 4, so I subtract that from 7. Excuse me. 7 minus 4 is 3, and I have one more digit to bring down, which is a 2. So I repeat, 4 will go into 32 8 times. 8 times 4 is 32. All of my digits in the dividend have been dropped down. I've got a 0 remainder. I'm done. So that tells me that 872 is equal to 218. So 4 goes into 872 218 times. Let me get a sip of water. Okay, part B. So for part B, we have 4,572 divided by 15. It'll be slightly harder because our dividend or our divisor is a 2-digit number, but it's the exact same process. So we have 4,572 divided by 15. Well, since the divisor is 2 digits, we need to start looking at the first 2 digits of the dividend. Looking to see how many times 15 will go into 4,572 is not something I can easily do, but I can do it step by step. So we want to see how many times will 15 go into 45. Well, 15 will go into 45 3 times. 3 times 15 is 45. So I subtract 45 and I get a 0, and I drop down my next digit. As soon as you drop a digit down, you have to put something in the quotient. So how many times will 15 go into 7? Well, 0 times. So I put a 0 up here in the quotient. 0 times 15 is 0. So I subtract 0 and I get a 7. And then I drop down the 2 and I repeat the process. So how many times does 15 go into 72? Well, 15 times 5 is 75. So we know 5 is too much. So that would tell me it's going to go in 4 times. And it just so happens that 4 times 15 is 60. So I subtract 60 and I'm left with 12. Now, we can do stuff with decimals, but at this point, we're just going to stop here. We've dropped everything down. We have a remainder. So we would say that 15 goes into 4,572, 304 times total, but then there's going to be a leftover 12. So that R12 just means, hey, we have a remainder of 12. There's 12 leftovers. Okay. Now, these same general ideas of long division are going to come up when we do division of a polynomial by a binomial. So make sure you understand dividing into that first digit is the same as dividing into the first term. And then we take something from the quotient, multiply it by the divisor, and subtract it. All of those same concepts are going to come into the division when algebra comes up. It's just a little messier, that's all. Okay. But I have faith that we can all do this.